Dear students, our first experiment name is determination of resistivity of wire by using voltage current graph. Okay, so that is the Ohm's law verification. So determination of resistivity of a given wire, one or two wires. So what is the formula we are using? Voltage, the Ohm's law is equal to potential difference is directly proportional to current flows through that wire, that is directly proportional. So V is equal to I into R, where V is the potential difference, I is the current, and R is the resistance of the wire. Then R is equal to V by I. If you perform, after completing the experiment, taking the value of voltage and current, now we are going to plot the graph in the experiment. In the graph, we are determining the slope. So the slope of this graph is equal to V by I. Y by X is the slope. So Y axis is voltage and X axis is the current. So Y by I is equal to slope. So this slope is equal to resistance of the wire. So what is the resistance formula? R is equal to rho L by A. So rho is equal to RA by L. So we know that what is the R value? R value is determined by using a VI graph slope value. Then A is the area of cross section and L is the length of the wire. So now we are going to do the experiment by using this formula. Dear students, this is the experimental setup for Ohm's law. So the Ohm's law first apparatus is battery eliminator. So are you able to see that? IC regulated DC power supply. So from the AC mains, the wire will be connected to DC power supply. So this DC power supply has 2 amps. Here the reading is given 2 volt, 4 volt, 6 volt and all. So we have to choose 2 to 6 volt battery eliminator. So we have to fix only 2 volt. Don't fix this reading 4 volt. Don't fix this reading 4 volt. So if you fix the 4 volt means we are using milliammeter. That milliammeter will damage. So always fix the position 2 volt only. So this is the positive terminal and this is the negative terminal. This is the positive terminal of the battery and this is the negative terminal of battery. This is the switch. Then this is the microammeter. So this is the microammeter, milliammeter. So milliammeter. So M is a milli, that is ammeter A. So it's a positive terminal, red color is a positive terminal and black color is a negative terminal of the ammeter. Then we are, so the milliammeter range, what type of the range we are taking? 0 to 500 milliammeter range. Then the voltmeter, what we are taking, that voltmeter means V. So we can differentiate the voltmeter and ammeter. How we can find that? If the V is given means voltmeter, then MA or A is given means ammeter, milliammeter, microammeter, we are seeing that. So what is the range? Range means the initial reading is 0 reading and final is a maximum of 5 volt this voltmeter will measure, and similarly maximum of 500 milliampere this ammeter will measure in the circuit. So this is the unknown wire. So are you able to see that the wire is wounded on the wooden scale? So this is the unknown resistance wire. We didn't know what is the resistance value and the resistivity value. Then this one is a rheostat. This one is a rheostat which is used to vary the voltage in the circuit. So this is a 2.8 amps, 38 ohms resistor rheostat. Rheostat has 2 connections. One connection is the upper connection, then another connection is the lower connection. We have the 2 lower connections. Any current will enter into the lower connections of the rheostat and it will be come out from the upper connections of the rheostat. So always input will be lower and output will be upper connections. So these are all then very important terms. That is a key. So this is the key. When the key, this is a open means the circuit is not connected. There is no connection between these 2 keys. If you insert this key, what will happen? The current will flow from this end to that end. So this is the key. So what are all the components? Battery eliminator, then milliammeter, voltmeter 0 to 5 volt range, then the rheostat, 30 ohms rheostat, then unknown wire, unknown resistance and resistivity wire, that is a simple wire, metal wire, then finally key. Now we are going to see what is the circuit of this experiment. So this is the circuit. The circuit consists of battery, eliminator, positive and negative. So from the positive of the battery eliminator, the wire is connected to positive terminal of the ammeter. So from the positive of the battery eliminator, the wire is connected to the positive terminal of the ammeter. Then from the negative of the ammeter, the wire is connected to the resistance wire and the another end is connected to the upper end of the rheostat. So what is that? From the negative terminal of the battery, where it is connected? It is connected to the wire. So this is the wire. So I am not connected to this knob. So the wire is now coming out. So I connected here. So this wire is a ammeter wire. So ammeter wire is connected to the unknown resistance wire. Then the another end of the ammeter wire is connected to which one? Rheostat upper end. Rheostat upper end. Then finally the rheostat lower end is connected to key and it is connected to negative terminal. So the rheostat lower end is this one and it is connected to the key. So I am not using key because in the battery eliminator itself it has a key. So I am not using the key, directly it is connected to negative terminal. Again I will say that from the positive terminal of the battery eliminator, it is connected to the milliammeter positive terminal. From the milliammeter negative terminal to the unknown resistance, one of the end. Then unknown resistance, another end is taken and connected to the rheostat upper end of the rheostat. Then the lower end of the rheostat is connected to the again to the DC power supply. Then we have a voltmeter. Voltmeter always connected in parallel with the resistor. So this is the voltmeter. So the voltmeter positive, listen carefully students, the voltmeter, this end is connected to the voltmeter positive and this end is connected to the voltmeter negative. So this end is connected, are you able to see this? This end is connected to voltmeter negative. So if you are interchange this one is connected to this, starting end is connected to the negative and ending end is connected to the positive, means the voltmeter deflection does not show. So connect correctly. So you have to follow the, what is that? Circuit diagram clearly, positive to negative and positive to negative, everything. So this is the circuit connection. What will happen when we switch on that? When I switch on this, I am able to observe that the voltmeter, what is the voltmeter here given? Here the voltage is 2 voltage only given. Here the 2 voltage only given in the battery eliminator. So the voltmeter shows maximum of 2 volt. So let us we take that the voltmeter reading is 0.4. So it will show not 0.4, 0.3. If the reading is 0.3, exactly 0.3, what is the ammeter reading? It is 100 milliampere, that is a milliampere. So 0 to the smaller division is a 50, then the small division is a 10. Are you able to understand clearly? Yes students? Listen, this is 100, 150, 200. So each and small division is a 10 milliampere. So this is a 0 to 50, this is a 60. So the voltmeter reading is a 0.3 and ammeter reading is 60. So that is the first reading in our experiment. So now I will note down this in the tabular column: voltmeter reading, ammeter reading and the resistance. What is a voltmeter reading? Yes, 0.3 volt. And ammeter reading is 60 milliampere. So here I have to mention it is not ampere, it is milliampere. Milliampere means into 10 power minus 3 ampere. It is a 60 value. Then for the next value, what we have to do that? Now you adjust this rheostat. If you adjust this rheostat this side, you are able to see that the voltmeter reading is varied. I will adjust this. Okay. So if I adjust this, so you have to maintain this voltmeter reading as voltmeter reading as initially we have 0.3, yes or no? Now we will fix 0.6. So the 0.3 we are increases. It is exactly in the 0.6 division. 0.51 0.6 division. What is the corresponding millimeter reading? Dear students, observe very clearly. Yes, this is the 0. Okay, 0, 50, 60, 70, 80 or 80 or so we have to stand in straight. So it is exactly 90. It shows 90. Are you able to see that? Before the 100th division it shows one division, that is a 90. The reading is 90. So the second one is 0.6. Answer is 90 milliampere. Then the third division. So what is the third reading? Again I will increase the rheostat value. Then what will happen? 1 point, that is a 0.6, 0.9. I keep it as a 0.9. So exactly 0.9. I hope you are able to see very clearly. I will show you clearly. Now it is visible. Yes, exactly 0.9. What is the corresponding milliampere reading? It is, what is this? So it is 150. It is 150. So the ammeter reading is 0.9. It is 150 millimeter. Again I will change this to, what is that? 1.2. So 1.2 means, what is the corresponding value? This corresponding value is 210. This corresponding value is 210. If the value is, fourth one is 1.2 means corresponding value is 210. Again, when the rheostat, further I will increase that. It comes to the end. So we will stop that. If you want, you can further increase and try it. If it comes 1.5 means it is our like, yes, very good. So it is a maximum voltage is 2 voltage only we are given in the circuit. So the voltmeter shows the 1.5 as a maximum one, not a maximum one. The rheostat will be over. So we are not further able to increase that. So this is a 1.5. So exactly at 1.5 deflection. Exactly at 1.5 deflection. What is the corresponding millimeter value? Try it. Yes, good. It is a 200, 250, 260. So it is 260 for 1.5 millimeter.